Okay, so this talk is about documentation, tools, and API design. So hopefully we can learn about writing good documentation and how good documentation can improve your code, which is cool. First, who am I? My name is Loren Segal. Some of you have used the tool called Yard before, or at least heard of it. I wrote Yard. It's about 5 years old now, so it's a pretty good doc tool. If you've never seen it, you should try it. I live in Montreal, Canada. I go to Concordia University. I'm studying a Master's of Software Engineering, and I'm studying formal verification in Ruby automatic program verification. This is my Twitter, GitHub, and blog if you want to check it out. But enough about me. Let's talk about documentation. So I have a couple of goals in this talk. The first one, I want you guys to learn why documentation matters. This is really important. I think documentation matters a lot, but I'm biased. The second goal is hopefully you guys can see what the elements of good documentation are and what the elements of bad documentation are and how to tell the difference, and hopefully how to write good documentation yourselves. Thirdly, I want to show you guys how tools can make your lives easier as documentation writers and how you can end up with better documentation. And finally, once you're writing good documentation, once you're using the tools properly, how you can use that documentation to improve your APIs and get better code out of it. But most importantly, if you guys come away with one thing from this talk, I want it to be a deep philosophical understanding of documentation. It's really hard to motivate yourselves to write documentation if you don't know why you're doing it. So I really want you guys to understand why I care so much about this stuff and why I'm talking about it. But I guess to really understand why documentation is important, we first have to figure out what documentation is. So a lot of people think that documentation is just writing a bunch of text and putting it inside of some HTML file and spitting it out to users. And it usually looks like this. Clearly, if it was this simple, I wouldn't be giving a talk on it. So there's more to it than just writing a bunch of text. But to get to that, we have to go through a bunch of basics. We have to talk about a bunch of basics. And I'm going to be pedantic, and I'm going to talk about something called protocols. Protocols are a way for machines to communicate with one another. We actually use them all the time. Some of them are HTTP, IRC, FTP, TCP, UDP, whatever. They're all protocols that we use every day. Why am I talking about protocols? Well, protocols are codified contracts. They are the way that we specify machines to talk to one another. If a protocol is not followed, the machine will fail. Well, why does this matter for documentation? Well, documentation is pretty much the same thing. Documentation is a contract. It's a contract with your users. If your documentation is wrong, things will go bad. If you guys think of documentation as a contract, if you guys just take this slide away from the talk, your documentation will automatically improve just by understanding that documentation is a contract with your users. And hopefully I can keep trying to drill this into you guys. So this is what a system might look like. This is a bunch of operations on a system, and you have file operations in the middle, and your users on the left, and your system on the right. Typically, the protocol would be the right side. You'd have a bunch of things on the right that are an implementation of some kind of protocol. On the left side, though, we have a different set of contracts. We have user contracts. So we have the methods. So you would call open to open a file. You would call read to open a file. You would call close to open a file. These are protocols that you have with the machine, with your API, effectively. And those protocols are specified through documentation. What specifies that we need to give it the R parameter? What specifies that we're going to get back a string of bytes in our read command? What does our close method do? Those are contracts with our users. This is the IRC protocol specification. This is the join command in the IRC protocol specification. It's a bunch of text describing what the join command does on IRC. The cool thing about this is a protocol specification. It's a contract, right? The cool thing about this is if you rename that join command and turn it into some method on a class, this would actually look a lot like code documentation. In fact, you have the parameters documented there, and you have the behavior of the system. This is a contract, and it becomes a contract with your users when you make it an API documentation. So contract sounds like a really scary word, and we don't like to really admit that we use contracts in Ruby. It's kind of like legalese and big and scary and stuff. I have a secret for you guys that you might not want to hear, but we actually love contracts in Ruby. And in fact, we use them all the time when we do things like RSpec. RSpec is a specification library, and specification is just another word for contract, really. We're writing contracts for our system all the time. And that's really great. We use contracts all the time. So you might be saying now, well, I'm writing specs. Why do I need to write documentation? I'm already writing contracts for my system. Well, specs are contracts, but they're not geared for your users. Specs are geared for your system. They tell you what your system does, but they don't tell your user how to do it. So although you can use specs for documentation, they don't really fill in the whole picture. However, we can reuse some of these specs as documentation, and we'll actually show you guys. I'll show you guys how we can do that kind of cool stuff when we talk about tools. But let's shift over a bit. Let's talk about bad documentation. So you guys have heard about code smells, right? Well, documentation has the same thing. Documentation has documentation smells. So there's ugly documentation as well. I'm going to only list a couple of them. There are a lot of kinds of documentation smells. I just want to get you guys a feel for what documentation smells can look like. The first one is complicated return values. So this is sort of like a specialization of a more general documentation smell of like complicated documentation. But this is a complicated return value. We have an OS class that has a processor info method that returns processor information about your system, imagine. And it's returning a list of 6 things. It returns a list of strings and numbers displaying CPU information of an OS, the CPU type, architecture, clock speed as an integer, vendor, temperature as an integer, voltage as an integer. It's a fairly long sentence, and imagine adding in extra fields into this method, and you'll only end up with an even longer sentence with different types and different things. And we haven't really even explained what those fields contain. Really, like we don't have examples of what those fields are. There are 2 ways to fix this kind of documentation thing. You can either change the documentation or you can change the code. I'm going to show you guys how to change the documentation here, and then we'll talk about how you can change the code later. There's this tool called Yard that will make the documentation look a little nicer. It's not really a solution. It's just sort of more of a Band-Aid. But if you use a tool that really understands types, you can actually separate out some of this information and at least present it better for you guys to write. And it does display better as well because you're separating out that information. So here we're actually only listing the names. We list this type separately, and then we just list the names, CPU type, architecture, clock speed. Obviously, if we go up to 10 fields with this, it's going to get really long as well. So we don't want to do something like that, but it's a start, right? So that's one kind of ugly kind of documentation thing. The other one is the title of this talk. It's called nodoc. This talk isn't actually about nodoc. I'm just talking about nodoc just here as an example of one kind of documentation smell. In fact, nodoc is RDoc only, so if you're using something like Yard or even Rocco or TomDoc, you won't have this problem. I just want to point out something that nodoc exemplifies, and one of the things that you should probably avoid when you're writing documentation. So again, nodoc isn't all bad. I just want to point that out. It just happens to be heavily abused by some people. I won't mention names. And the real problem is that there's no style guide to tell you when to use it. So one thing we do with Yard is that every time we have a new declaration or tag, we always specify exactly when you should use it and exactly when you should not use something. And I think that makes documentation better for everyone. But in the absence of that, we have nodoc abuse. Nodoc abuse comes in generally 2 forms. The first form is that people use it to hide public methods. That's kind of bad. The second thing people do is they use it as a placeholder for undocumented code. So when they don't want to document something, they just put nodoc there, and they'll come back to it later. This is the HTTP party class. Some of you have probably used this before. This is a public method in one of the classes that is the default options method. It's nodoced. So someone's basically saying, I explicitly want to hide this from my API documentation. So there's a general rule of thumb about this, is that you should decide what you want to hide when you generate the output, not when you write the content. Think HTML and CSS, right? We're used to this. This is a principle we know very well, separating presentation and content. You want to do that in documentation as well. So you don't want to do something like this where you're saying, here's my content, the default options method and whatever documentation is with it. You don't want to say hide this. You want your tool to say hide this. You want your tool to do that kind of presentation stuff. Your tool is the one handling all the presentation. So you just want to focus on the documentation here. You never want to write, hide this. You could say you should hide this unless the user says something. You can give it hints, but you don't want to forcibly hide things. Because whenever you do something like that, your user can't find that method anymore. And remember, it's a public method. They can actually call that. If they went into IRB and they said, give me all the methods, they'll get that method and they'll be like, where is this documented? So you don't want to do that. The other problem is that you get ambiguity when you do something like this. It's unclear what the intent of that docstring was. Was it because it was supposed to be a private method and it just wasn't private? Was it it should be obvious to you and therefore I don't need to document it? Or was it, I'm going to document it later and we'll fill that in later and we'll publish it then? So it's unclear, and you don't want that ambiguity in your docs. It makes it really bad. So those are two of the example kind of things you don't want to do. Let's talk about things you do want to do. So let's talk about good documentation. There's really no silver bullet to writing good documentation. The real trick here is just to describe the behavior of the method or class. There's no secret way of doing this any better than any of you know how. It's really like something you have to do, and you'll get better at it as you practice. There are some tips to make some things better. One of the tips I like to tell people about is to avoid the first person. Saying we or I is generally bad practice. Saying you is okay. You might want to avoid that in some cases, but saying you don't use the first person, basically. The second thing is what you want to do is the first sentence in your doc string should summarize the method. Your users will be scanning a list of, think about your users. Your users are scanning a string class, and there's tons of documentation in there. And they are trying to find the method that they need. They're not going to read the full doc string for every single method just to find what they need. If your doc string is summarized in the first sentence, it'll be a lot easier for your users to find what they are looking for. So that's just a good practice behavior. Finally, you want to leave out implementation details unless they affect usage. So most of us already know that we shouldn't talk about implementation details in our docs. There is that little thing, unless they affect usage. There are situations where implementation details matter. If you had like a file system operation that gives you back a file handle that you have to clean up later, that information is an implementation detail that will actually matter for the user. So you want to put that in that case. Examples. You want to put examples hopefully in every single public API method you guys have. If you guys have a public API and you're a library or framework, you want to have examples for every single public method. Private methods you don't need examples for, but it's generally good to have examples everywhere so you know what you're doing. In Yard, we use the example tag. That's a Yard tag that we use for examples, if you know Yard. Mention any usage caveats. So again, just like implementation details, if there's anything that your users have to know about to use this method, like, oh wow, it's going to delete the database when you finish this call, that's probably something you should mention. And in Yard, we use the note tag. Through that, you could just put an extra paragraph if using another tool. Again, so the last thing is references. So references are also good to put in. A lot of people avoid this, but if you have, like, if this method depends on another method, like you need to call open before you can do a query on this database, it's good to have a reference just to improve the navigation of your docs so that users know where to go, what they need to look for. The last thing is list acceptable parameter and return types. And yes, multiple types and duck types are valid. So that's a scary concept, types. Let's talk about that for a sec. Rubyists, us as Rubyists, we don't like to admit that we use types sometimes. But the reality is that Ruby has them. So they're there and they matter. In fact, Ruby's a strongly typed language, so types matter a lot. In fact, if you have this, if you have an example of JavaScript of string 6 divided by 2, you'll get back 3. But in Ruby, you'll get back an error. Until this kind of reality changes in our Ruby world, types are going to matter for us. So we have to specify them. You could argue that, well, I'll just name my parameters properly and my method names properly, and my users will understand the story, what I'm trying to say. Well, the reality is that parameter names don't tell the full story. For example, if you have find name, we can assume that it accepts John. But what about the symbol John? Will that work? Do we know? It's not obvious, right? You have to say what you're accepting. If you're the only way to figure that out is to try it, and your users aren't going to try every single method just to find out what works and what doesn't. Here's an even more obvious one, less obvious one. Parse template. Who here can guess what object is being required here? Does anybody know? Quick yell out. Does anyone want to yell it out really quick what they think it is? No one? String? Well, what about a template object? So string might work. What about both? What about IO? Yeah, could be an IO. If I hear more than 2 answers, then it's too ambiguous, right? This stuff should be specified, especially because it's going to matter. The fortunate thing is that a type is not a class in Ruby. So a lot of us like to say that when we're talking about types, we're talking about classes. Well, in Ruby, types are not classes. So we don't have to worry too much about specifying types because we can specify duck types. Duck types are also types. Structural types are types as well. You could specify modules. They don't have to be classes. So specify types. They're good for you. They make your documentation much more consistent. So let's bring this all back into an example of good documentation. This is just a regular attribute accessor method that accesses through the square bracket syntax. You could see an example of you could see the doc string right up top, the description of the behavior. As you can see, it's really simple. It doesn't have to be complicated to be good. The first sentence happens to be the summary and the full doc string in this case. If there was more information, you would have that same sentence there and then elaborate further on. We have an example over there. We can have multiple examples if it's more complicated. We have the parameter, and you can see how we're specifying a duck type. So we can specify duck types, and you can see how we're returning multiple objects. So this is all yard syntax. You can do it in your own way if you're not using yard. I like to do it like this because I wrote yard. And so, yeah, you can return multiple objects. Object if it returns something, nil if it doesn't. And we have a reference to the setter method, just in case the user wants to know. Yes, actually, you can ask now. So I actually use Boolean, and Yard actually defines a couple of meta types, as we call them. Boolean is one of them. Capital Boolean. So we actually use the class name Boolean. Hopefully one day Ruby will introduce the class name Boolean to have a proper inheritance tree, but we accept the Yard convention is to use Boolean in that case. You could probably say if you weren't using Yard, if you wrote Boolean, people would understand you, and I think that would be valid. There are some other cases like, I forget the other cases, but there are some other meta types that we use in Yard. So let's talk about tools. So we know how to write good documentation, but good documentation is still a pain in the ass to write. Let's make it easier. There are a couple things tools do for us. There's actually a lot of things cool tools can do for us. I'm only going to mention a couple of them. The first one is that tools can remove duplication. So we saw before the docs and specs discussion that we had. We have documentation and we have specs on the right. There is some overlap between them. Sometimes our specs are basically describing the exact behavior of our method. We can reuse that we can reuse those specs, and the way we reuse that is we use tools, right? Now, this talk isn't about Yard, but since I wrote Yard, I know a lot about it. So Yard is a documentation tool that's been around for 4 years now, and it has a lot of plugin support. It has macros to reduce duplication, specifically to reduce duplication of documentation. And it has a really extensible design, so you can actually use it as a tool just to do lots of really cool documentation related, even non-documentation related things, relying on comments and source code and stuff like that. One of the plugins that was written is called the Yard RSpec plugin that is available on Ruby Gems. And this one actually literally does what we described before. It embeds your specs into your documentation, so you have the specs right in there, and you can actually reuse that specification information. So that's something a tool can do. There's also one for Cucumber, that you can display your Cucumber steps alongside your documentation, and you can have it feed back into your method docs. This is all stuff that can really help you lower the bar of writing docs, so you don't have to duplicate documentation everywhere. You can use macros. I'm not going to discuss macros, but you can look at Yard's. You can go to the Yard site and check out macros. It helps a lot for this kind of stuff. The other thing tools can do is they can audit code. So I'm not going to talk about this a lot either. If you actually specify parameter and return types, there's a lot of really cool things you can do, like generate tests to make sure that your code actually returns a string, and that's actually really useful for you testing your API and verifying random things about your API. That can actually be really cool, and actually that makes up part of the research I do with Ruby and automatic program verification. So there's a lot of cool things you can do around auditing. So now that we know how to write code and write documentation and write good documentation and use tools, let's talk about how we can use that stuff to improve our APIs and get better documentation and code out of it. There's this thing called document-driven development that maybe some of you have heard about, probably not. I'm going to talk about this. I'm not talking specifically about document-driven development. There's probably some really good literature on it. This is my take on the subject. But anyway, yeah. Tom Preston Werner wrote this blog last year in late August called README-driven development, in which he basically said, if you guys are writing a new library or something and you're going to publish it, before you ever write code, write your README first. And in doing so, you will not only explain what your library does, but you'll also have some API specification for your users, so they'll know exactly what to expect from your API and exactly how to use it before you write code. Not only does that help them, but it helps you because you have a plan for what to implement and exactly how to implement it. Tom goes on to say that basically README-driven development is not document-driven development because README-driven development is more agile. Well, he is right. He's only right on a matter of scale, though. RDD is basically just a subset of DDD. If you can imagine all your docs in that big circle and your READMEs over there, you can imagine that you have little circles everywhere else. And in fact, you do have multiple little components all over your system that you can do RDD for. So if RDD works on the small scale for some API, there's no reason why we can't just scale that up. And in fact, we scale stuff up all the time when we do web stuff and web scale and stuff like that. So we know a lot about scale as software engineers. If you can scale this stuff up properly, it's very easy to do. The real crux of this is that RDD is just about planning ahead. And in fact, as document-driven development is really the same thing. It's just on a different scale, and document-driven development is also about planning ahead. So I know what you're thinking. You're thinking, well, I have to design my whole system up front now, and I'm going to be talking about waterfalls for the rest of the next 15 minutes. So no. Document-driven development is not about writing all your docs first. Document-driven development is about writing and validating against your documentation. You write some code, you write some docs, you validate, and you iterate. You don't do it all up front. In fact, we'll see why it sucks to do that all at the end. So actually, DDD looks more like this. You write docs for one method, you implement the method, and then you validate your docs against your code, and you make sure that it's in sync, right? You could scale this up a bit. You can go up to like a class or a module or maybe a set of modules or classes. I wouldn't go much further than that, but you could scale this up just a bit if you wanted to. You don't have to do it per method. You could also do it the other way around. You could write your code first, and then you could write your docs if you don't like writing code first. You can always do that. You can iterate on code until you have some stable thing, and then write the docs for that component. The important thing is that it's part of your process. It's part of your development cycle, and that every time you don't move on to the next component until you have the docs there. So why do we care about validating our code against our docs? Well, let's go back to contracts. We're writing contracts for our users, right? We want to make sure that stuff works. And the only way we can validate that our contract is valid with our users is if we validate it against the code. And the only way we can validate it properly is if we make it part of our development cycle. Basically, all we're doing is we're codifying the API, right? We're just writing this stuff down as we're implementing it. Codifying the API basically will tell us when our API sucks, and we'll see that in a sec. It basically lets us improve our API, and we win, basically. Let's show you how we can actually use this kind of iteration of document-driven design to actually detect a bad API and improve it and see why this works. So we have our processor info method from before with the 6 things that it returns. And we said that returning an array makes things kind of ugly, right, to document. And this is what we ended up with as a docs. So let's say the documentation is too complicated. Let's make this simpler by changing the code. Let's turn this into a hash, maybe. Maybe that'll work, right? So we turn this into a hash, and I'm only going to list the 3 things just to make it easier to show. This looks okay, right? It looks a little cleaner. At least maybe it'll be easier to document. Well, it turns out that it's actually more complicated to document than the array. In fact, the yard syntax is actually exemplifying exactly where this is more complicated. That we've actually introduced a new class, a new type. We've introduced 3 new keys, discrete keys that the user has to know about. So we've added all this stuff, and by explaining this, by writing this doc down, we've actually just explained how much more complicated our API has gotten. In fact, I haven't even been able to fit in all the extra details that I had in the other ones without making this enormous. So wow, geez, our API just got really complex just by refactoring it, right? So our documentation is telling us something by being so complicated to write down into English. It's telling us that our API doesn't fit into our abstraction. It's telling us that our API is too complicated, and we need a new abstraction to fit that complexity. So how do we usually encapsulate data when we have we're returning this big thing with a bunch of keys in it? How do we encapsulate a bunch of data? We put it inside of a class, right? So our documentation is telling us if you want to simplify this, you need a new abstraction. Put this inside of a class. So let's do that. Let's put this inside of a class, right? What we end up with is we have this processor info method that returns a single class, and we have 1 line of docs. And the user knows immediately what it's returning. If they want to find out what's inside that, they know exactly what that is. They go to that class, they see exactly what each of those fields are. And each of those things is 1 simple line of English that defines what it is. And even here, we have all this extra space. We can define examples. We can define what you would expect from that thing. So we have the x86 architecture or ARM architecture, what it would return. For CPU speed, we can actually see now how we're going to encode it as an integer. We're going to show it as megahertz. So 3.4 gigahertz would turn into 3400. We actually get all of this information in now, stuff that we didn't have before, and we don't have to put it in this huge big English sentence that doesn't really parse properly for users. Our documentation got so much it just got so much cleaner, right? Well, so this kind of exercise can actually be applied to a lot of APIs that are out there, and I challenge you guys to go and try this with some of yours or some APIs that you know of. You could probably, if you can't explain it in writing or even out loud if you want to do that, if you can't explain it in an easy, simple English sentence, it's probably too complicated and it needs to be refactored. So by using this stuff, by using this documentation as you go kind of stuff, you can actually find what APIs are too complicated and where your really complicated designs are. But the thing is, you need to actually write the documentation as you go. You can't leave it until the end. So some lessons we hopefully got out of this, maybe you guys hopefully got out of this. The first one, besides using tools is great, and besides some examples of good documentation, hopefully you got out that your documentation is a contract with your users. That's really important. If you guys think about documentation as a contract with your users, and you guys commit to an API, because that's what you're doing when you're writing a contract, if you commit to something, you will have a more reliable API. You will have more reliable, a much more consistent API. You will have a better implementation just by committing to a specific implementation. So that tells us why we should document code. It tells us we should document code because our users will get a more consistent API. But why should we document as we go? Well, if we write out these contracts as we go, we have a way to validate that contract as we write it, and we can find out when it doesn't make sense. And if it doesn't make sense, we have a way to fix it. It should be fairly clear how to fix these things. So in fact, the only real waterfall in document-driven design is actually leaving your docs to the end, because then you only know what's wrong when you write your docs at the end. You're never gonna be able to fix all those problems with your docs when your API is already published and you just are starting to write your docs and you're like, oh wow, this API doesn't make any sense. So hopefully you guys start documenting as you go, and if you do that, you will end up with much better code, much better APIs, and much better systems. So, any questions? Yes.
I've recently done a lot of work around RDoc.
Yes.
And I found a great deal of pain, particularly in the lexing and the parsing of how it processes the common blocks. I found Yard to not be so encumbered, so I like Yard.
Thank you.
Yeah, so.
Thank you.
My question to you is Yard going to be continually maintained as a separate but equal environment, or do you think Yard will eventually migrate into the code review distribution?
Sorry, can you repeat that last one?
Well, do you think Yard will ever become part of the code review distribution?
That's a good question. So he asked if I think Yard will ever become part of the standard library. That's my goal. We've been designing for that in mind, with that in mind all the time. So Yard has never had any external dependencies because that seems to be a requirement to get into the standard library. We try to maintain that. We don't have any C APIs that are hard coded in. I am hoping that one day that happens. I am not in charge of how that works. And it has been brought up on a couple mailing lists before. My suggestion would be to talk to people you know and try to encourage them to make that change. I talked to some people. We're working on it, basically, in short. We're working on it. Any questions? Yes.
So it seems like with RDoc and Yard, the documentation is still coupled to it's for developers, it's coupled to the public instance methods. Is there a way to do documentation that's really for like imagine you have a Sinatra app that made a web API. Mm-hmm. Can you write the docs in there and generate something that's for that API?
So if I understand your question correctly, you're saying that there are different APIs for different users? Is that what your question is?
Yeah, just like documentation for, instead of this chunk of docs for this method, really documenting what you can do from the outside.
Okay, so yeah, there actually are. There is in Yard has a REST plugin that can actually document REST commands as like get and put commands, if that's what your question is. There's a Yard REST plugin that lets you basically has custom tags for like action, or I think action or request or a request method, I think. And you could put in like this is a post to / the URI that it gives you, and you could put in the actual like logical parameters that it's expecting, that the web API is expecting. And there is the Yard REST plugin will do that for you, and I think it generates some pretty nifty HTML stuff. But just to elaborate on that, Yard doesn't actually define a public and private only. Yard actually has an API tag in which you can say this is a developer API, so this is for my developers. This is like an internal API, or this is like a plugin API. So this is for if you want to develop on plugins, you can develop plugins. And what you can do with that in a tooling is when you give that kind of API hint, you could say, okay, Yard, generate all the docs for everything in the plugin API, and it'll just generate those methods, and you could just publish that separately. And you could do the same thing with a REST API as well, even without that plugin. Yeah.
You had mentioned nodoc as a smell, but you did say that you thought it was appropriate sometimes. I was wondering when you thought it was.
So there's this really weird edge case in which you have public methods that are only public because they talk to other classes, but they're not really supposed to be public. It's just that you can't call a method on another class from another class. It has to be public, and Ruby doesn't have like a friend idiom. So in that case, it's effectively not supposed to be a public API method. It's supposed to be like a internal API. The way we do that in Yard is by saying API internal or something like that. There's also a private tag in Yard which defines it as like logically private, but not actually physically, like not actually private. And you could say exclude all internal methods in the tool and just hide it like that. But if someone wanted to see those internal methods, they just do it regularly, right? Any other questions?
Is there a plugin that will generate the RSpecs or the cucumbers from the documentation?
That's a good question. There is, so I did write a plugin in showing some examples of how you can use Yard. I did write a plugin that lets you embed RSpec specifications inside your doc strings, and you just like use the it tag and it should do this, and you can embed your specs there. I wouldn't necessarily recommend doing that for complex specs, but you could theoretically have a plugin that would do Cucumber. I guess Cucumber would be a better scenario for that. And you can actually have a plugin that would embed Cucumber and then generate out the Cucumber steps files or whatever they are. Yeah.
So JS doc is a really similar concept, even in like, the syntax of it, but it's like slightly different. I'm just kind of curious, is there a plugin to generate like JavaScript documentation using Yard, or is it specifically for Ruby?
So we only have Ruby parsers. The Yard is extensible in the sense that you can actually write your own parser for another language and just have the handlers run on your code if you've generated the right AST. So you can write a parser for JS that generates a Ruby-like AST, and it'll work the same. So you can actually extend it like that. No questions? All right. Well, thank you very much.